The shrew launched itself at the snake's face, not away from it, at it. A creature roughly the size of your thumb, weighing less than a slice of bread, hurled its entire body towards a set of jaws that could swallow it whole without chewing. The snake recoiled, actually recoiled, and in that half second of hesitation, the shrew vanished into the leaf litter like it had never been there at all. I watched the snake sit there for a long moment, tongue flicking, looking deeply confused. Snakes don't really do confusion well. Their faces aren't built for it. But if a snake could look like it was reconsidering its life choices, that was the look. And me? I was standing maybe 4 feet away, perfectly still, perfectly transparent, perfectly dead. Yep, that's me. You're probably wondering how I ended up here. Oh, hey there. I didn't get bitten by a snake, if that's the theory forming in your head. My death was significantly less cinematic. A ladder, a gutter, and an argument with gravity I lost decisively. But somewhere in the process of being dead for what I can only describe as an inconveniently long time, I started doing what apparently every ghost does eventually. I started watching animals. A lot of animals, for a long time, with nothing else on the calendar. And one thing kept bothering me, in that itchy, can't let it go way. Why do the smallest animals on Earth act like they have nothing to lose, while the biggest ones tiptoe around like they're carrying a full cup of coffee through a crowded subway car? You'd think it'd be the opposite. Big equals strong equals confident, right? That's human logic. That's action movie logic. Bigger guy wins the bar fight. Nature looked at that assumption and laughed so hard it fell over. So let's talk about why the tiniest creatures on this planet are, pound for pound, audacious lunatics, and why the giants are often the most cautious things alive. Part 1. The math nobody taught you. Here's the first thing that wrecked my brain when I started paying attention. Size doesn't just change how strong an animal is, it changes the entire physics of being alive. A mouse can fall out of a 5-story building and walk away. Not limp away, walk away. Mildly annoyed, looking for snacks. A horse falls off a curb wrong and you're calling a vet with a very serious face. Why? Because as an animal gets bigger, its mass increases by the cube of its size, but the surface area and air resistance only increases by the square. Smaller animals have more drag relative to their weight, so they fall slower, hit softer, and survive harder. This isn't a fun fact. This is a survival cheat code. A shrew can take risks that would liquefy a deer because the universe is, quite literally, gentler with small things when it comes to impact. So when you watch a squirrel fling itself off a branch that should absolutely end its life and it just bounces and runs away like nothing happened, that's not bravery in the way we think of bravery. That's an animal that evolved with a built-in airbag system humans can only dream about. Evolution looked at the problem of falling and said, what if we just made some animals basically weightless paper? And somehow that worked. Part 2. Metabolism is a ticking clock, and small animals hear it loudest. Here's where it gets darker in a way I genuinely respect. Small mammals burn through energy at an absolutely deranged rate compared to large ones. A shrew's heart can beat over 1,000 times a minute. It has to eat nearly its own body weight in food every single day or it dies. Not gets weak, dies, within hours. Compare that to an elephant which can comfortably skip a meal and barely notice. This changes the entire risk calculation of being alive. For a shrew, standing around being cautious isn't safe. It's a death sentence with extra steps. Every hour spent hiding instead of hunting is an hour closer to starving. So evolution didn't have the luxury of building a cautious shrew. A cautious shrew is a dead shrew. The aggressive, ambush anything, lunge first, ask questions never shrew is the one that survives long enough to pass on its genes. This is less fearless warrior and more tiny caffeinated accountant who knows the company goes bankrupt by Thursday if nobody closes a sale today. Meanwhile, a grizzly bear can sit on a decision for 10 minutes. It has fat reserves. It has time. Time is the one luxury small animals never get to have, and the absence of time is exactly what makes them reckless. Fast fact 1. Shrews are so metabolically extreme that some species can starve to death after going without food for as little as 2 to 3 hours. Fast fact 2. A hummingbird's heart rate can exceed 1,200 beats per minute during flight. For comparison, that's faster than the wing beats of most insects you'd actually call fast. Which brings us to something even stranger. Part 3. The bigger you are, the more you have to lose. Here's a phrase I picked up from decades of lurking near zoologists who didn't know I was there. State-dependent risk-taking. Translation: how much risk an animal is willing to take depends on what it stands to lose if things go wrong. A large animal, especially a long-lived one like an elephant, a whale, or a human, represents an enormous biological investment. Years of growth, years of potential future reproduction. If that animal dies in a stupid fight over a tree it doesn't even need, evolution just lost an enormous amount of accumulated potential. A small animal with a lifespan measured in months is a different kind of bet entirely. It's not save for retirement, it's spend it all today, because there might not be a tomorrow regardless of what you do. This is why elephants will often back away from confrontations a smaller animal would charge straight into. It's not cowardice, it's portfolio management. You don't gamble your retirement account on a coin flip, but you might gamble $5 you found on the sidewalk. Small animals are, biologically speaking, playing with house money. All the time. Every day. Forever. Scenario 1. You're standing in a forest clearing. A squirrel a few feet away spots a hawk circling overhead. Instead of bolting into the nearest hole, it freezes, watches, and sometimes, and this part genuinely surprised researchers, it makes a specific alarm call aimed directly at the predator. Not a warning to other squirrels, a message to the hawk itself, essentially saying, I see you, I know exactly where you are, don't bother. This is called pursuit-deterrent signaling, and it's been documented in ground squirrels facing rattlesnakes too. The squirrel isn't hiding, it's standing its ground and broadcasting confidence at the thing that wants to eat it. Why would a creature do something so audacious? Because hesitation is expensive when you're small, and information is cheap to give away once a predator already knows where you are. Telling a hawk, I clocked you, can actually convince the hawk to hunt something easier instead. You thought predators always go for whatever looks weakest. Nature looked at that and said, sometimes they go for whoever looks dumbest. Don't be the dumb one. Evolution breakdown. Let's slow down and actually unpack why pursuit-deterrent signaling evolved at all, because on the surface, it sounds insane. Announcing your location to a predator should be the worst possible strategy, except predators rely heavily on the element of surprise. A successful ambush often depends on the prey not knowing it's being hunted yet. The moment that surprise is gone, the energy cost of the hunt goes up dramatically for the predator, while the odds of success go down. So a prey animal that confidently signals, I know you're there, is essentially telling the predator, this hunt is no longer cheap, go find an easier meal. It only works, though, if the signal is honest, if the animal really has noticed the predator and really is ready to flee the instant it needs to. Bluffing badly here gets you killed. So this behavior had to evolve alongside genuinely excellent threat detection. The confidence isn't empty, it's backed by real sensory receipts. This is the squirrel equivalent of a poker player going all in with a straight face, except the squirrel actually has the cards. Myth 1. Small animals are just naturally fearless. True or false? False. Completely false. And this one bugs me because it gets repeated constantly. Small animals are not fearless. Many of them show measurable physiological stress responses, elevated cortisol, increased heart rate, the whole anxious biochemical cocktail in dangerous situations, just like larger animals do. The difference isn't the presence of fear, it's what they do with it. Fear for a small animal living on a razor's edge energy budget has to be processed and acted on fast because freezing too long is its own kind of death sentence. So natural selection favored small animals whose fear response triggers immediate, decisive action rather than prolonged deliberation. It's not the absence of fear, it's fear with a much shorter fuse. Humans love romanticizing this as bravery. It's closer to forced efficiency. Imagine being so broke that you can't afford to think about a decision for more than half a second before acting on it. That's most small mammals basically all the time, forever. But before we get there, let's talk about something documentaries almost never explain properly. Part 4. Surface area is the secret hero of this whole story. I promised this would come back, and it's about to come back in a way that explains an enormous amount of small animal behavior all at once. Small animals lose heat incredibly fast because they have a huge amount of surface area relative to their body volume. This means many small mammals are in a constant, exhausting battle against losing heat to the environment. A shrew isn't just racing a clock on food, it's racing a clock on temperature simultaneously at all times. This is why so many small mammals are almost pathologically active. Stillness isn't peaceful for them. Stillness is potentially fatal. Movement generates heat, hunting generates food. Staying calm and cautious generates nothing except a slowly dropping body temperature and a slowly draining energy tank. Big animals like elephants have the opposite problem entirely. They struggle to release heat, not retain it, which is part of why elephants have those enormous ears acting like inbuilt radiators. An elephant's risk calculus includes don't overheat by doing anything dramatic. A shrew's risk calculus includes do something dramatic immediately or die slowly of cold and hunger at the same time. This is less size determines personality and more of size determines an entire invisible physics simulation running underneath every decision an animal makes, and we just call the output personality because it's easier to explain thermodynamics at a dinner party. Reality check. Here's where I want to actually ground this in something measurable because I promised I wouldn't just throw vibes at you. Researchers studying predator-prey interactions across body sizes have repeatedly found that smaller prey species tend to have shorter flight initiation distances relative to their body size in certain contexts. Essentially, they let predators get proportionately closer before reacting, then react with extreme speed and decisiveness. Larger animals, by contrast, often show what's called risk-averse foraging, abandoning food sources at the slightest hint of danger because the cost of losing a meal is much lower for them than the cost of losing their life. To put that in a number that means something, a mouse's reaction time to a sudden visual threat can be measured in tens of milliseconds, faster than you can consciously register movement. For comparison, the average human reflex to a simple visual stimulus is around 200 to 250 milliseconds, roughly 10 times slower. You are, neurologically speaking, an unbelievably slow creature next to a mouse. Try not to take that personally. I did, and it didn't help. This is also part of why mice are so famously hard to catch with your hands. It's not luck, it's not cuteness powers. Their entire nervous system is built like a hair trigger alarm, wired directly to their muscles, with almost nothing in between. What is actually going through its head? Let's actually sit inside the moment for a second. The shrew lunging at the snake, the squirrel calling out the hawk, the mouse vanishing before your hand finishes moving. What's known? Many small mammals process sensory information and initiate motor responses with remarkably short neural pathways, sometimes bypassing higher-order decision-making almost entirely in true emergencies. This is sometimes called a fast pathway versus a slow pathway and threat response. What's likely? In the highest stakes moments, a small animal isn't deliberating the way we imagine deliberation. There probably isn't a tiny internal monologue weighing options. It's closer to a reflex shaped by millions of years of, the animals who hesitated here are not your ancestors. What's hypothesized and genuinely still debated, whether animals like squirrels experience something resembling calculated confidence during pursuit-deterrent signaling, or whether it's a fixed action pattern triggered automatically when certain conditions are met. Scientists are honestly still arguing about how much decision is really happening versus how much is wiring on autopilot. I'm not going to pretend I have the answer. I'm dead, not omniscient, different department entirely. What I can tell you from literal centuries of just standing around watching this stuff happen is that it looks like courage from the outside and it functions like courage in terms of outcomes, but the internal experience driving it might be something closer to a reflex with excellent PR. Speaking of terrible decisions, let's talk about humans for a second because you knew this was coming. Part 5. Humans get this backwards constantly. You've probably heard someone say something like, "Don't worry, it's more scared of you than you are of it," usually right before getting bitten by something they had absolutely no business approaching. Here's the problem with that phrase. It's often technically true and completely useless as safety advice. A small animal being more scared doesn't mean it's going to run. For a lot of small species, fear and aggression aren't opposites. They're often the exact same wire. Fear is frequently the trigger for the aggressive lunge, not the brake on it.
This is why cornering small wild animals, raccoons, possums, even something as tiny as a chipmunk, tends to produce far more aggressive, committed attacks than cornering something massive like a deer, which usually just wants to find literally any exit that isn't you. You thought you'd outsmart a creature that's been practicing decisive last resort violence for millions of generations. Spoiler, you were wrong, and there's a small but real chance you're currently nursing a scar that agrees with me. Unexpected exception 1, when big animals get suddenly terrifyingly brave. Now, before this turns into small good, big boring, let's talk about the moments the whole rule flips completely inside out. Mothers. Across nearly every mammal species, maternal defense of offspring overrides the normal caution by size rule almost entirely. An elephant that would otherwise avoid confrontation will charge a lion pride without a flicker of hesitation if her calf is threatened. A moose, an animal that under normal circumstances is famously, almost comically avoidant of conflict, becomes one of the most dangerous large mammals in North America the moment a calf is nearby, statistically causing more human injuries annually than most predators people are actually scared of. The reason ties right back to that earlier idea of investment. A calf represents years of future reproductive potential just standing there on wobbly legs. The math that normally favors caution flips completely once that math includes protecting an investment that valuable. Suddenly, the giant has everything to lose by not acting, instead of everything to lose by acting. This is the one scenario where size stops predicting bravery, because the variable driving the behavior isn't size anymore, it's stakes, and nothing raises stakes faster than a baby. Fast fact 3. Moose are responsible for more human injuries per year in parts of North America than bears, largely due to defensive charges, particularly from cows protecting calves. Fast fact 4. Hippos, despite their bulk, are considered among the most dangerous large mammals in Africa, specifically because their threat hold is so low. They don't wait for confirmed danger. They react to perceived territorial intrusion almost instantly, more like a small animal's hair trigger system running inside an enormous body. And that hippo fact is honestly the perfect bridge into something I find genuinely fascinating. Part 6. Hippos are cheating, and I love it. Here's where the size equals caution rule gets gloriously messy. Hippos are enormous, and yet they behave with the twitchy, immediate aggression you'd expect from something 100th their size.
Why? Because hippos occupy a strange ecological niche where their main vulnerability isn't predators. Adult hippos have very few natural predators, but rather territorial competition with other hippos. Plus the simple fact that despite their size, they're surprisingly vulnerable in deep water if caught off guard or separated from the group. Their aggression isn't about fear of being eaten, it's about fiercely guarding a resource, water territory, that their entire social and survival structure depends on. This is the equivalent of a massive office building suddenly enforcing the strictest possible parking spot rules, not because anyone's going to steal the building, but because the parking spot is the actual scarce resource everyone's fighting over. Size predicts a lot of behavior. It doesn't predict everything. Ecology always gets a vote. Here's where nature gets weird, again, because apparently it never stops. Part 7, the insect loophole. If you want to see small equals reckless taken to its most extreme conclusion, skip mammals entirely and look at insects. Honeybees will sting in defense of the hive knowing, in the purely mechanical, non-conscious sense, that the act will kill them. The barbed stinger tears free of their body after use. This is, from an individual survival standpoint, the single worst possible decision an organism could make, and evolution selected for it anyway because the unit of survival that matters here isn't the individual bee, it's the colony. This is the moment the entire small equals more reckless because of personal risk math framework gets turned completely inside out. The bee isn't being brave for itself. It's not even really making an individual gamble the way a shrew is. It's a disposable component in a much larger superorganism that calculated across millions of years that some percentage of workers dying defensively is an acceptable cost for colony survival. This is less individual courage and more evolution running corporate level risk assessment using bodies instead of spreadsheets, and somehow that's even darker than anything I've said so far, and I opened with a snake fight. Reality check continued.
A honeybee colony can contain 20,000 to 60,000 individuals. To put the stinging death trade-off into perspective, losing a few hundred defenders in repelling a serious threat is, in colony survival math, roughly equivalent to a city losing a small fraction of 1% of its population to successfully repel an invasion that would have otherwise destroyed the entire city. Brutal arithmetic, effective arithmetic. Myth 2. Predators always pick the smallest, weakest target. True or false? Mostly false, and this one surprises people every time. Predators frequently select targets based on detectability and predictability far more than raw size or weakness. An animal standing still, hesitating, or behaving unpredictably erratically can actually draw more predatory attention than one moving with calm, confident purpose, because confident movement reads as, "this one knows what it's doing and won't be easy," while hesitation reads as, "this one is confused," and confusion is opportunity. This is part of why the bold signal-sending squirrel from earlier sometimes gets ignored by the hawk entirely, while a different squirrel frozen in indecisive panic gets targeted instead. Predators, much like opportunistic con artists, are drawn to uncertainty. Confidence, even performed confidence, can be its own form of camouflage, which is deeply unfair to every anxious creature on Earth, myself included, but here we are. Scenario 2. You're a tourist on safari. You see a warthog, cute, low to the ground, looks harmless, looks honestly a little goofy. Then it spots a predator, and instead of fleeing immediately into the brush, it sprints directly towards its burrow, backwards, tail first, so it can keep facing the threat the entire time, ready to defend the entrance the second it arrives. A warthog backing into its den facing outward isn't poor spatial awareness, it's tactical retreat with a guaranteed final stand built in, every single time, automatically. It never gets caught facing the wrong direction. Evolution didn't make the warthog brave, it made the warthog unable to retreat stupidly even if it wanted to. Part 8. The exception that breaks everything. Apex predators. Let's talk about lions for a second, because lions throw a wrench directly into everything we've discussed. Lions are large, and yet individual lions, especially young or inexperienced ones, show measurable, well-documented hesitation before attacking genuinely dangerous prey like adult buffalo or elephants. This looks like caution. It largely is caution, but it's a completely different category of caution than a deer's caution. It's not "I might die" generally, it's specifically "I know this particular prey item can kill me because I've either seen it happen or I've been taught through pride dynamics and experience that this target is dangerous." This introduces something most of the script so far hasn't touched: learned risk assessment versus instinctive risk assessment. Lion cubs aren't born knowing buffalo are dangerous. They learn it, sometimes from watching, sometimes from getting badly hurt themselves. Their caution is partly software, not just hardware. Small non-mammal animals mostly don't get the luxury of a learning curve. A shrew that needs 3 attempts to learn a predator is dangerous typically doesn't survive to attempt number 2. Big, longer-living predators can afford an education. Small, fast-living prey usually can't. This is in its own way the entire size and bravery rule from a completely different angle, not just metabolism and physics, but how much time an animal even gets to learn from mistakes before mistakes become fatal. Fast fact 5. Studies of lion hunting behavior have found that inexperienced lions are significantly more likely to be injured or killed attempting to hunt large, dangerous prey like buffalo, while experienced, particularly those that have hunted in successful groups, show measurably more selective, cautious targeting. And that's only half the story, because there's a flip side to all of this that almost nobody talks about. Part 9. The audacity has a cost. I don't want you walking away thinking small animals are running some flawless evolutionary cheat code with zero downside. The recklessness has a brutal price tag. Small mammal mortality rates in the wild are staggering. A huge percentage of shrews, voles, and mice never live to see their first birthday. Many die within weeks or months of being born. This isn't despite their bold, fast twitch strategy, it's partly because of it. Living fast and reacting decisively saves you from many individual threats, but the overall lifestyle, constant activity, constant exposure, constant energy desperation, is a high-variance gamble repeated daily, and eventually the dice land badly. Every single time, for every single individual, eventually. Large animals trade audacity for longevity. They live slower, breed less frequently, but individually survive far longer on average. Small animals trade longevity for raw reproductive output, having many offspring quickly, accepting that most won't survive, betting on volume instead of individual durability. This is less small animals are braver and more small animals are running a high-risk, high-frequency strategy, and large animals are running a low-risk, low-frequency strategy. And bravery is just the visible symptom of which strategy an animal happens to be stuck running. Neither one is wrong. Evolution doesn't grade on heroism. It grades on whoever's still around to reproduce. Myth 3. Bravery is a personality trait in animals.
True or false? Complicated, but mostly false in the way humans usually mean it. What looks like bravery is, in most documented cases, an emergent outcome of body size, metabolic demand, lifespan, predation pressure, and social structure all interacting at once. It's not a fixed character trait sitting inside an animal like a stat on a video game character sheet. It's closer to the output of an equation where size is one of the heaviest variables in the formula. This doesn't make it less impressive. If anything, it makes it more impressive because it means every brave act you've ever watched a small animal perform is the visible tip of an enormous, ancient, ruthlessly tested mathematical system running underneath, refined across more failed attempts and dead individuals than you could possibly count. You're not watching courage. You're watching millions of years of trial and error wearing courage as a costume, and honestly, it's a really convincing costume. Part final. Things I wish I'd known while I was still alive. I spent a fair amount of my actual living years assuming size equaled danger and danger equaled distance, and that was the whole equation. Turns out the equation had about 9 more variables I never bothered learning, and a couple of them would have genuinely helped me not get bitten that one time by a chipmunk that in hindsight had every biological reason to be unreasonable. So here's what I'd tell you if I'd known it before becoming professionally dead. 1. Small does not mean harmless. A cornered small animal is often far more likely to commit fully to an attack than a cornered large one because for many small species, fear and aggression run through the same wiring. 2. Confident, steady movement around wildlife is generally safer than frantic, hesitant movement because predators and defensive animals alike often read hesitation as opportunity or threat far more than they read size. 3. Never approach any animal, regardless of size, that's near offspring. The size-based caution rule disappears completely the moment a parent is protecting young, and this applies to animals as massive as moose and as small as a mother possum. 4. If you're ever near a small mammal defensive, remember it's likely operating on a starvation clock measured in hours, not days. Its decision-making isn't casual. It is, biologically, the most urgent thing happening in its entire world at that moment. 5. Respect water-adjacent large animals like hippos differently than you'd respect land-based ones their size. Their aggression threshold is dramatically lower than their bulk would suggest, closer to a small animal's hair trigger system than a typical large mammal's caution. 6. The next time something tiny does something that looks suicidally bold, you're not watching foolishness. You're watching an organism that literally cannot afford caution, executing the only strategy evolution left available to it. I've been watching this planet operate without a body for what feels like an unreasonable stretch of time now. Storms come and go, generations of foxes I've quietly nicknamed get born, live their tiny chaotic lives, and pass on, sometimes within view of the same tree. And the thing that never stops getting me is this. Every single creature out there, from the trembling shrew to the lumbering hippo, is running a survival strategy perfectly tuned to its own body, its own clock, its own brutal arithmetic. None of it is bravery, exactly, and all of it is bravery, exactly. Depends which afternoon you ask me, honestly. Anyway, I should go. There's a badger about to make an extremely questionable decision near a fox den, and I have genuinely nowhere else to be. If you want more videos like this, subscribe.